Good morning, everyone. Myself, Mumkin Nancy Priya, Assistant Professor in the Department of Electrical and Electronics Engineering. In this semester, I'm handling W25601, Basic Electrical and Electronics Engineering. In today's session, we are going to discuss about the most commonly used motor in day-to-day life, that is the single-phase induction motor. The introduction is how many of you have a ceiling fans in your house, washing machine, water pump? All these appliances use single phase motors because in our home we get only the single phase supply. So we are all using the single phase motor with the help of in the application of washing machine, water pump, and all. So power is supplied to a home as a single phase. Three phase is available only in industries. So motors were designed to work with the single phase supply. So in single phase motor are less efficient than the three phase motor. But since three phase is not available in houses, we use the single phase motors. The single phase induction motor is not a self-starting. This is why. What do you mean by self-starting? A motor that starts rotating automatically when supply is given is called self-starting. For example, three-phase motor. It is a self-starting, and the single-phase motor is not a self-starting. So, what are the types of the single-phase motor? In the single-phase induction motor, it is classified into three types. That is a single-phase induction motor, single-phase synchronous motor, and commutator motors. Where in single-phase induction motor, it is classified into three types. That is the split-phase, capacitor, and shaded pole. Whereas in single-phase synchronous motor, we are classified into reluctance motor and hysteresis motor. While in commutator motors, we are classified into repulsion motor and universal motor. What is the induction motor? It is mostly commonly used in fans and pumps, the water pumps. In synchronous motor, used very constant speed is required. Wherever the constant speed in clock, timer, we are using the synchronous motor. In universal motor, which is used in the mixer grinder, drilling machines, because they can run both on AC and DC. So universal motor which work on both AC and DC. So today we have mainly focus upon the single phase motor. This is a single phase motor. In this single phase motor, have a squirrel cage rotor and a single distributed stator winding. The stator is the stationary part and the rotor is the rotating part. In this rotating part, we are having a squirrel cage. So such a motor does not develop any starting torque. So in this, the motor is not a self-starting. So it produces the alternating magnetic field. So the AC supply is given to the stator winding. It create a magnetic field. This magnetic field is pulsating. So this is not rotating. So the self in a single phase induction motor is not a self-starting motor. And if the rotor is started by auxiliary means, the motor will quickly attain the final speed. So the strange behavior of single phase induction motor can be explained on the basis of double field revolving theory. This is the squirrel cage rotor and this is the stationary part. This is the stator winding. Here we are giving a single phase supply. Then a pulsating in this motor, a pulsating field cannot produce a starting torque. We are giving a supply in the screw cage for the stationary winding, so it produces a magnetic field. The magnetic field is pulsating because it is an on and off, and it is not a rotating. So this is explained by using the double field revolving theory. The pulsating magnetic field can be resolved into the two types and the two field. One rotating field is the clockwise direction and the another rotating field is the anti-clockwise direction. Both fields have the equal magnitude. At starting condition, torque produced by both fields is equal and opposite. So if there is the equal and opposite, the net starting torque is zero, so that the motor will not start automatically. So, but if we manually rotate the rotor, one torque becomes dominant, then the motor accelerates. So the one thing is the motor rotating field in the clockwise and anti-clockwise. So it will rotate in the both field is equal and opposite. So the net starting torque is zero, so that the motor will not start at the point. So if we rotate it manually, one torque becomes dominant because the opposite force become less no. So the one becomes dominant, so the motor accelerates. The making of single phase induction motor is a self-starting. If the motor does not start automatically, what should we do? We must create a rotating magnetic field. By creating the phase difference between the two current, what should we do? By an auxiliary winding, it's a starting winding, we have to create a phase difference between the two current. So now motor has a two two windings. One is the main winding and another one is the starting winding. So in the main winding and starting winding, both winding carry current with the phase difference. A rotating magnetic field is produced. Then the motor starts. So after reaching the sufficient speed, starting winding is connected. So after reaching the sufficient speed, the starting winding is disconnected. So that the motor will, we have to make the single phase induction motor as a self-starting motor. In the split phase also started by two-phase motor, action through using an auxiliary or starting winding. And the capacitor motor is also have a two-phase motor through the auxiliary and a capacitor. Here we are using a capacitor because it's a capacitor motor. And the third one produced by means of the shaded coil around the portion of a whole structure. This is the main winding and this is the starting winding. This starting winding is used to start the rotor. And if it is the capacitor motor, we have to add some capacitor in this starting winding. Next is the single split phase induction motor. What is meant by split phase induction motor? It is very important. First, we have to explain about the construction. In this, the stator has two windings. That is, one is the main winding and another is the starting winding. The main important difference is in this main winding, it has a low resistance and high inductance. Think about that. The main winding has a low resistance and high inductance, whereas in starting winding, it has a high resistance and low inductance. So that is the main difference. So why different resistance and inductance are approached here to create the phase difference between the current. That's all. So because the inductive current lags more and the resistive current lags less. So because there is a more resistive value than the inductor. So the inductive current lags more and the resistive current lags less. So the phase difference of 25 degree to 30 degrees created. So the phase difference produces the weak rotating field. So in this we have creating the magnetic field and by using this starting winding we have to rotate this rotor and this rotor we have a less high resistance and low inductance for the starting winding and for the main winding have the low resistance and high inductance. So they have the phase difference. So we are clearly draw the picture of the phase difference. So it creates a current. Next is the operation. I have explained step by step. First, the supply is given. Remember that first the supply is given. Both the winding, that is main winding and the starting winding get energized. If whatever the supply is given, the coil get energized. Then the phase difference is created. Third point is the phase difference is created. And the fourth one is the rotating magnetic field being formed. First, the supply is given, then the coil get energized, and the third one is the phase difference created between the main winding and starting winding. Then the rotating magnetic field is formed, so the motor starts rotating. At 75% of synchronous speed, the motor reaches the 75% of synchronous speed, the centrifugal switch is open. What is the centrifugal switch? The centrifugal switch is connected in series with the starting winding. Here see, this is the centrifugal switch. It is connected in series with the starting winding. It opens automatically when the speed increases. When the synchronous motor rotates, reaches 75% of synchronous speed. This rotor reaches 75% of what is the synchronous speed? 1500 RPM. No. So it reaches 75% of 1500 RPM means then the centrifugal switch gets open. What is the centrifugal switch? Which is connected series with the starting winding, and it opens automatically when the speed increases and disconnects the starting winding. So there is no magnetic field from the starting winding. So the motor runs only on the main winding. So what will happen? The motor which runs only based upon the main winding. So the characteristic, what does the characteristic means? It is a simple construction and economical, and it's a constant speed, have a speed variation only 2 to 5% from no load to full load because the slip is very small. And for the moderate starting torque, it's not suitable for the heavy load starting. And the main application is fans, washing machines, oil burners, small machine tools for with the power rating of 60 watt to 250 watt. Next is the torque speed characteristics. In x-axis, we are calculating the we are marking the speed, and y-axis we are marking the torque. At a start point, the torque is very low. The torque is very low. The speed increases as the torque increases near the synchronous speed. The torque slightly decreases. The speed is slightly less than the synchronous speed. So, if the speed increases, the torque is low at the first point, the torque is low, then the speed increases, the torque also increases. Near the synchronous speed, at the time of the synchronous speed, the torque decreases slightly and the speed is slightly less than the synchronous speed because the induction motor always runs with the slip. So, what is the synchronous formula? Ns is equals to 120 F by P. F is the frequency and P is the number of poles. So what we are discussed in the these are the references. What we have discussed in today's session, we have discussed about the single phase induction motor, why the single phase induction motor is not self-starting, and how the pulsating magnetic field is produced, what is the double field revolving theory, how the axillary winding creates a phase difference, and what is the split phase motor uses the resistance difference. These are the concepts we have discussed in today's session. These are the references, and thank you for watching. We will discuss the next video in next.